is going to cover the basic security concerns. We see them from different perspectives: the issues, vulnerabilities, frauds, and the countermeasures. Before that, recap on and we'll finish the final part based on the view of transactions. The work with transactions led us to understand that there are properties we have to adjust on each transaction in order to talk about the secure transaction that will happen whenever we're implementing a process based on transactions. The asset properties. Right after we discuss the modes, transactions modes. By the modes, actually, we have to understand that the transaction has to be either admitted, to be accepted and executed. What has to be delivering, it has to be registered or recorded or saved or admitted or executed. Otherwise, all the activities have to be rolled back in the sense of non-admitting the group of activities or the group of queries, commands has been launched earlier. So either we admit, means we commit the transaction, or we cancel, means roll back the group of transactions. Based on those two views, we present four modes. The commitment to be either implicitly or explicitly set, or to be set by the program itself, or to commit. Other than that, there are views based on the transaction activity. If you are talking about nested transactions, so we wish to describe the batch scoped mode. We explain just in a while. Executing a transaction now has to put us as developers in a situation that whether we admit to commit a transaction or to cancel, to roll back a transaction, or to set the computer decide whether the circumstances or the commitment to be set. Otherwise, we are going to do a multi commitment and rollback activities based on the transaction in question. It is a batch scoped mode. This view would lead us actually to know that the transaction, it is not something that to be rectified into a query or a list of queries to execute. No, there is a view via which we terminate transaction. This is the best word we use to describe this mode, or the transaction mode. It is the termination of a transaction, of a given transaction. Remember that the transaction might be seen as a nested group of nested transactions because of the batch scoped mode. So what it concerns the auto-commitment, the auto-commit transactions, it is a context of a single query to execute. So the computer will understand that since you are just executing a select, or you are just executing an insert, or an update, alt, truncate, whatever, it is a single query. So the computer will auto-commit that. Not the computer, but the system in question will auto-commit that. Side. Okay, the explicit mode or the explicit transaction, it is a context of indicating explicitly the start of the transaction and the end of the transaction. So we have to explicitly set a startup of a transaction and explicitly write and indicate to the program that the transaction has to be committed or rolled back based on some circumstances. Constraints would push us to decide whether to commit or to roll back. Means we are going to do the transaction for test. We preview and then after we roll back, we not commit. Or we're going to do the group of queries, execute them, and then after commit the execution. This is an implicit, sorry, this is an explicit explicit mode. The implicit, the third one, the implicit transaction is a context of just create and indicating that the transaction is being executed, but at the end only we mention a commit or a rollback statement. So you just start within the program or within the project in question, the transaction would be actually launched, and at the end, just one statement to indicate whether to commit or to roll back. This is an implicit indication. This is an implicit mode. So we are not mentioning the startup of a transaction, but at the end of a group of executions, we commit or we roll back. It is one statement to launch. So implicitly, we are setting up the commit or the rollback statement. Fourth mode, the transaction mode number 4, the bus scoped transaction is a mode via which actually we are let's say intentionally and specifically we are utilizing the commit and rollback as many as required, but based on the use of the feature, given the abbreviation MAS, multiple active result sets, it's a context via which, briefly to make you understand, only we are utilizing the commit and the rollback as many as required. It is required, or they are required by the transaction in question, and not only in the end of the list of queries that the transaction would cover, but we might find nested transactions, means blocks in between. We may commit portion number 1, portion number 2. We may roll back to portion number 3, commit portion number 4, and so on, until the end of the transaction, the group of queries means. So implicitly and explicitly, we are stating the commit and the rollback statements within a context of multiple active result sets, transactions, let's say view. And because of this only, we are saying that the bus scope transaction is being set. So it is because of the combination of, or the adoption of the multi commitment and multi rollback statement setup. But here, any questions, please? In exactly what I just said right now regarding the bus scoped transaction or bus scope transactions, we said that they are this mode of transaction, actually it is described because of the use of the implicit and explicit rollback and commit statements from within the body of the transaction, and at the end also. We are not specifically setting up the mode at the end, implicit or explicit rollback and commit, but even within the body of the transaction, because the transaction is that. Here we understand that there are nested transactions. So this puts us in a situation to describe the transaction differently. It is not an implicit transaction, it is not an explicit transaction, since there are modes, or let's say commitment and rollback statements mentioned from within the body of the transaction. In between the statements, in between the queries, there are commits and rollback statements. This is a bus scope, but the bus scope actually is applicable on a mass type of transactions or transact SQL. What does it mean, mass transact SQL? I asked you, do you have a question? Nobody asked. Are you with me here? Should I take the attendance now? Said, are you here? Said, the question is to you. I was describing that the mode number 4, which is there is no number, there is no we are just counting for type, fourth mode, for transaction mode, the bus scope transaction. It is a mode via which we see the application of the commit and rollback statements as many times as required by the transaction, but this mode is applicable with the mass transactions, the mass TSQL, transact SQL, let's say transactions. What is a mass? So here we have to understand clearly what is this type of TSQL transactions. As per the title, multiple active result sets. Here we are delivering transactions that would actually deliver more than one result per transaction. The same transaction would give us more than one result. We would not have one return at the end. We would not have one outcome at the end. We would have more than that. MARS, mass, multiple active result sets, types or TSQL transactions. In this regard, this type of transactions we cannot finalize by using a one commit statement. We will be actually find a big difficulty in terminating such transaction, admitting such transaction by just one statement, either one commit or one rollback. So it is not something easy to terminate. It is not 100% impossible. No. Remember that we are having more than one execution, than one outcome. Each outcome has to be either admitted, commit, or rollback, cancelled. So how to do that with one commit? If you put them sequentially one after the other as two queries, for example, so this is one transaction. We are not talking about a query because remember the first mode, the auto commit transaction, we said that the auto commit, it is to be recognized by the system in question if the transaction is covering only one query, so automatically would be actually admitted. The system will go for an auto commit transaction. An auto commit transaction means implicitly and explicitly, it would be actually set by the system itself. The commit will be passed by the system if the transaction is covering only one query. So the bash scope at the end was applicable on the mass described transactions. The transaction cannot have one query. If it is more than one query, for example, select, insert, insert, select, 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 insert, insert. Simple queries, simply. So they are not transactions. They are a group of queries within one transaction. Thus, the system in question would be following the orders of the developer, whether explicitly or implicitly, to commit at the end. But there are transactions that they have more than one result to be set. For example, as per the result, we say a return. We saw in the last lab, that we may go for exceptions. We might have two outcomes based on a condition. So we will have two cases to take care of. The program has to execute either the first or the second. Or maybe if we're going with a switch case, we will have a variety of queries to execute based on a condition also. Either the first or the second or the third or the fourth, and so on. So, and they would not be executed all of them at the same time. No, one of them or two of them or some of them will be executed, or there will be a node or something like that. So the mode has to be set for each block, for each part, for each condition. Thus, we see a mass here, a multiple active result sets. The block one has to be executed and give a result. The second block has to be executed and give a result. The third, the fourth, and so on. Multiple active result sets. To such process, implicit and explicit transactions cannot be described here, because both they are coming into action and both they can be set, and more than one commit or more than one rollback might be executed the same transaction fully. Thus here we describe the bash scope transaction. The bash scoped transaction. Let's go for an example actually here for the implicit first of all, before the example. The auto commit here, see the case here is simple. It's a simple query to execute, no more no less. Someone, Ahmed Ismail, came. Okay. If you do not have any questions, let's go on. So still on the bash scoped transactions and the mass transactions and mass queries. Remember that the bash scope transactions, they are to be applicable. They are to be applied on the mass transactions, mass TSQL. Mass stands for the multiple active result sets. Actually, they are given more than one result, more than one return. You may say that it covers the one query based. Theoretically, yes, but in real plane, no. The theory, because it is a definition, but on real plane, one query based transaction, it is to be decided by the definition. Actually to be committed by the query, by the system itself. It's just one simple query, so it is not the case. to describe it with the mass-based transactions with the SQL. So there is one feature. There is one feature to make us understand more, because here actually remember we are just seeing the theory. Now we are going to go for the explanation, the technical explanation of what is this batch scope, and because of this batch scope, we'll understand clearly the implicit and explicit commitment or rollback. Technical descriptions push us to understand when and what to use the batch scope, what technical descriptions, what technical tools, what technicalities, what technology to use to apply the batch scope transaction. So remember, batch scope transaction, it is an overview of, we may say nested group of transactions. I'm using the nested word. Why? Because from within the body of the transaction itself, we will have more than one commit and rollback statement. Technologies that we as developers have to consider, take care of when building up a mass transaction. I'm using the word mass. It means multiple active result set transaction, multiple active result set type transaction, is the use of save points. Yeah, since we said earlier that the mass transaction would actually make us see a sort of nested transactions, one inside the other. So the one inside the internal has to be executed also, and has to indicate an outcome or to give a return, something like that. So in matter of time, there is a sequential order. The external transaction has to be launched, then the internal transaction has to be executed fully, committed or rolled back. Then after we come back to the external transaction. This is a time sequential process, or time-based process. First, second. We cannot trespass. Nested transactions push us to execute the external first, then the second, then we terminate the internal, the inside one. Then after we come back to the external to terminate it. External, internal, internal, external. The process has to be like this. We cannot go beyond that. That's the technology. Here, when we describe the transaction this way, there are save points, which is a technology used to set up a time positions within the project or the transaction itself, the transaction body. The save points is a keyword to utilize to indicate a breakpoint for which the developer or the program can refer for a need. Position number 1, position number 2, position number 3, begin of transaction 2, begin of transaction 3, end of the transaction number 4 or number n. Those are save points that the program will refer to. They are to be indicated by the developer, no? And the developer also will make the program refer to in case of necessity. Before committing the final transaction, he might return and commit the transaction number 1 because of the save points. Something like that. Under the mass mode, save points cannot be utilized. Multiple active result sets, save points cannot be utilized. Technology says like that. We will see an example right now when we use the mass mode, let's say, or mass type, and also another example where we are not using the mass type. Let's start with the non-mass transaction. Means a transaction that has more than one query as a body. We may say that it is batch scoped. We'll see. It is not a mass, so it's not a batch scoped. But let's see the non-mass transaction where we can use the save points. So non-mass transaction here, we have an start. I'm subdividing the transaction into two slides. I'm sorry for the, just give me a second, please. Okay, this non-mass transaction actually it is I'm subdivided into two slides, but because of the size only, we have a start implicitly set, and we have an end at the end of the transaction actually, but we have a commit here. In between, in the body itself, we have actually statement stating the mode, which is a rollback here. Save point number one, which is clearly stated here. Save tran, which is transaction shortcut. Actually, those are two keywords here. Save tran. Given the name here, it's a position. It's let's say time position that the program can refer to. We are going to push the program to save the transaction at this position. So once we need to refer to it in future time process, we start from the beginning, begin run, and he's going to go through the statements here, the queries here, save the transaction at this position, keeps going on. Yes, here queries again, queries. He's going to, for a necessity or another, see here the commands, see minus means command, we know he is a command. We are having, for a reason or another, we need to roll back the last 5 statements. We need to roll back, yeah, the last statements we did so far, we need to roll back here. So we are going to roll back until what? The time save point, the save point here, what we are saving here, we need to roll it back. The save point, we need to roll it back. So this way, the program would be able to roll back to where the save point was saved, was indicated here. And then after he will continue again. Okay, then after continue again, where here actually he will do this portion, whatever the queries are. Then after commit. The queries we see here, they are only title of example, and the queries they are insert, select, update, the habitual, the regular SQL queries. No more, no less. We are having more than one, let's say, commit statement. Yes, absolutely, but because of the save points, we are able to admit and roll back based on some necessities, some needs, because we are needing to cancel some queries, so we roll back. Otherwise, we will continue. And we are able to roll back to a specific point due to what? To the save point, save run. Save point, actually, it's a word that we are, it's a keyword, it's a user defined, but those are predefined keywords. Save, the run, it's the indication of the transaction that has been started here. And here we are saving the status. In saving not the status, but saving the process at this position, we can, this is a referral point. If we do not refer to it in a future time within the transaction, so there is no how. The program will keep going on. As if you are indicating a plate, it's an information. This is a place that you can stand on in future times. That's it. If you use, okay, it is available for you to use as a developer, as an implement, let's say once the program is in debug mode. Or if you don't use, so خلاص, it's there. This is one. We do not have more than one return here. We don't have more than one, let's say, command here. We have queries only, simply select, 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 and so on. Simply, we see another example now where we see the remarks here. We have query number one, we have command number one, which is actually here to be seen specifically. Why? Because we are having we are using the .NET technology here, actually, because of the context of return, or let's say execution. We are executing more than one command. Command number one, for example, it would fulfill the outcome of the table number one into control number one. And the command number two, still page number two, is the same transaction. It is the same transaction. Command number two, the slide number 18, I'm going to go. Yeah, command number two would fulfill an outcome of table number two into control number two. So we have two complete different, let's say, queries or commands. They are not queries, but they are commands. We are passing a connection number one and connection number, let's say the same connection might be happening, but two commands, command number one and command number two. A bind to a resource number one and a bind to a resource number two to fulfill table number one and table number two. Thus, if the command number one fails, there is no harm on the command number two, since they are completely separate. But both of them, they would be actually executed, whatever the execution inside. This is the command number one, what would do the transaction number one, and the command number two, the transaction related to the command number two. They are completely separate. The execution would be actually either yes committed, or in case of let's say exception, we saw in the lab, there will be actually maybe a rollback or something like that. So there will be an alert and another block to be executed. This, the block starts here and it ends here. This is the exception handling. The transaction, we may say that it ends here, but in case of transaction exception, an exception handling case would be launched. So the commitment here, it is not to be set more than one time. So in a batch scoped mode, we cannot commit more than one time. See here now actually final conclusion here as per the definition of our mass transaction here. The commit has been described to us at the end of this transaction. Two commands we have in this example: command number one, command number two. Yes, this is command number two, and this is command number one. Command number two and command number one. That's it. So what I just want you to memorize is that the transaction modes, they are ways via which we, whether we commit or we roll back a transaction. We have the auto commit if the transaction is holding only one query, is one query base. Otherwise, we have either the implicit or explicit. Manually, we indicate the start and the end of the transaction, so it's an explicit transaction. Manually, we just leave the transaction, execute the list of the queries, and manually we set up the commit or rollback statement at the end, so it's an implicit transaction, an implicit mode. Other than that, if we are having more than one, let's say, result-based. Now, technically, we speak. You have to understand technically if we have more than one result or more than one, let's say, binding result, resource, and outcome. So we have to go for the bus scope transaction, which is a mode that can be applied only on the mass-based types of transactions. Those are the four modes of the TSQL. I will stop the recording. If you have any questions, you may raise, and I'm going to take the attendance also now. Please, if you hear your name, just say yes.